So, surface area. We should be getting down on this now. Like, what is surface area?
The area of the surface. It's just the amount that the surface takes up.
Yeah, amount it takes to cover something, amount it takes up, right? Same idea. We started off, we talked about 2D shapes, how much it takes to cover a desk, right? A 2D shape or a wall, 2D shape. And then we started doing bigger things, right? So we started doing like, okay, how about the area of a whole box? So all those shapes on the outside. How about the area of a pop can, right? Like the entire cylinder, outside, top, bottom, everything. But I like to start off every day with what the heck we're doing so that when you see a surface area question in the future, you understand and remember, oh yeah, surface area is the amount it takes to cover something.
There is a fight. Wouldn't there be like have to be a round two for the people that lost?
For sure. That's why it happens every year. It just keeps making charity money.
What about like the substitute?
All the proceeds go to charity.
I'll try.
I feel like butterfly. Should definitely.
He'd be good in there.
Yeah. Maybe you versus butterfly.
Formula. I'd be freed. He'd beat me up. Formula for a cone. Yeah, hit me.
So it's pi r2 plus pi lr.
Good job. So area of a cone is pi r squared. And then it's pi r, and then it's the slant height. So it's like the distance up that side. And there's different letters you'll see depending on different websites. So some of them use L, some of them use S, some of them use H. I'm going to put S for slant height. I don't want the height of the cone from the middle to the top. I want on the outside, so it's on that angle. When you think about this formula, because I actually don't use the formula very often. When you think about this formula, it's broken down into two pieces. The pi r squared part, that's the circle on the cone. So if you're looking at that cone below, that represents down here. The second part of the formula, this part, is the actual like cone part. I don't know how else to describe it, right? It's we'll say the incline. I like that. It's all this other stuff. So when I go to calculate the area of a cone, I actually don't do this formula. What I do is all right, what's the area of the circle part? Now what's the area of the top part? So then I can kind of break it down into the two sections. Makes my life easier. Also helps for when I have shapes where maybe I don't want to do the circle part. Maybe the cone's covered or something, and I don't want that circle, and I just want the outside. So that's when we're also going to see that maybe you don't want that whole formula all the time. Cool, let's start off. Area of that cone. Again, I like to break it down into sections. So this first section I'm going to do is this circle. The area of a circle is pi times r squared. Pi is 3.14. R is the radius. That's from the middle of the circle to the outside of the circle. On this question, it told me that my radius from the middle to the outside would be 3. It would be half of that distance they gave me. It would be 6. Perfect. That means the area of my circle is pi times 3 squared. Remember that squared just means times itself. So it's really pi times 3 again. You throw that into your calculator. Remember, we're going to write down about 3 decimals worth. Oh boy, I hit plus. 28.274. That's the circle part of the cone. The next part we're going to do is this like cone part, this outside part. I'm going to call it the cone part. What do we call it for? The incline part. If you want to call it the incline part, I like that. So this part up here that's kind of slanting. The formula for that is pi r s.
Pi times.
And that s is the slant height. Which in this case is, you got over there, pi times 3 times 9.
You know what sucks when you make a long calculation and you make one mistake and go here?
That is the worst. If you throw that in your calculator, so you got pi times 9 times 3 is 84.823. By taking a shape and breaking it into chunks like this, it kind of simplifies your calculations so you don't have to do massive calculations, big long strings of it. It also allows us to then total everything up, which is kind of nice that we always follow this same formula or same process of find all the sides, add it all up. My total would be 28.274 plus 84.823. When you add those two numbers up, you get 113.1 after you round it, right? It should have been 113.09. 09 rounds to 0.1. And like all of our questions, we say it's inches squared. You got to always put that in on your last calculation.
Sure. And I'm done this one. Can I go wash?
Yeah, you can go wash right now. I think I've got that after. So remember to include your units in your final answer. Right? That's the best way to do it. That's surface area of a cone. Not that bad, right? Like it's break into pieces. Circle, incline, or cone part. And life should be pretty good. I think we have 2 more examples that we'll do together. Yep, 2 more. I'll do one more with you just to kind of follow along so we're on the same track. And then I'll let you do the third one on your own. So if we're looking at this second one, and they said calculate the area of that thing. The first thing I want to do is break this into pieces. I'm like, well, here we go. I got a circle right there. I can calculate the area of a circle. It equals pi r squared. In this case, the radius is given to you from the middle to the edge, so it's 8 inches. So I'm doing pi times 8 squared. If you don't have a squared button, remember it's just times itself. So that's pi times 8 times 8. That gives me 201.061 dot dot dot. The next section on a cone would be that incline area. This part. To calculate that part, I'm going to put incline again because I like that you use that. That's pi times r times s. S is the slant height. It's got to be that outside height number. For us, it's pi times 8 times 18. Throw that in your calculator. Pi times 8 times 18. And you get 452.389 dot dot dot.
I have no idea what I'm doing.
What'd you get?
244.
When you did pi times 8 times 18? That's what you got?
Yeah. Pi times r.
Yeah, which is 8.
Squared. Go plus pi.
Do you times by 4 or by 8?
No, I just
Okay, we'll total this up, then I'll come look, or he can help you out right now.
Is the formula not pi times r squared plus pi times r plus the slant?
Times the slant.
Oh, it's
Times the slant. There you go. couldn't get it. Okay, your total. You want to add the circle, add the incline. When you add those two numbers together, 201.061 plus 452.389, you get, yep, 0.45, so I'll call it 0.5. And that was inches squared. Wicked. That's area of a cone. I'll give you a moment to work through that next one, and then I'll go over it with you. And I want you to just try it on your own first. See how you do.
If I got this wrong.
Okay, if you're not done, that's fine. I'm going to go over it right now. So the circle is the blue spot that I have. It's pi r squared. In this case, r is 4, right? So you want to take your radius or your diameter, cut it in half to get 4. When you put that in your calculator, remember that's pi times 4 times 4. So you're not doing pi times 4 times 2, pi times 4 times 4.
Oh, we got the same answer. We chose.
Hey, that's good. That means you should get 50.265 ... right? It keeps going. The incline area, the cone part, like that outside section, is pi times r times s. That's pi times 4 times 12. S is that slant height, right? That weird angle cut. If you put that in, you got 150.796. Then you total it up by adding all those sides, you get 201.1 yards squared. A yard is not a normal measurement for us, right? That's an American measurement.
Imperial.
Imperial, yeah. That's a better term than saying American. I just don't know anyone else who uses it other than the Americans. They have weird measurements sometimes, but it is good to understand roughly what it is because we do use their measurements sometimes. Like inches. That's an imperial, that's an American measurement, but we still use inches all the time.
We use centimeters?
A yard, we use centimeters, meters, anything
with
meters.
I thought they used centimeters.
Yeah, like on your ID, it'll say your measurement, but in centimeters, because that's the Canadian system. We don't use imperial. But if I said, how tall are you?
Oh, hey, I didn't.
Yeah, kilograms too. Like kilograms is us and pounds is the American. So on your license, it actually says kilograms and centimeters, which is different. A yard is roughly a meter. So if you're trying to wonder, it's about a meter. Cool. I'll hand out your guys' practice composite shapes. A composite shape just means shapes put together. Okay. Our strategy is not going to change. We're going to try to label sides, write them out, and then total it all up. It's just that it's a lot more challenging now to find all those sides. I'm going to start.
Do you do the bottom side?
You do one first.
Yeah, we're always going to do the bottom unless it otherwise tells us like not to. So for instance, like underneath here, you can't really see, but you're going to do it anyway.
Well, what about
Same with the back side we're going to do.
What about when there are two squares, right, or rectangles, and the rectangle's on top of the other rectangle?
Yeah.
Do you do underneath that top rectangle?
So if we had like this, and then we had this on top of it,
Yeah,
you would not do the bottom of this calculator,
Okay.
right? Because it's not needing covering because it's already covered, right? You wouldn't have to do either that square that I'm covering. So that's going to be our tricky part of like how to manage that. And I do have some good tricks.
So it's like if you can cover paint with it, then
Bingo. If you would paint it like the way it is, yeah. We're going to start off with kind of the easier sides because that's always like the best way to tackle it, right? So let's do this front right here.
Wait, does their schedule change because it's day 2?
Your schedule will always be the same.
Don't you do one shape first and then the other?
I'll show you my strategy. So we're going to call this the front of the bottom. When I do the front of the bottom, that's going to be length times width. That's clearly a rectangle, right? So length is 13. The width is the height of that thing, which is 4. So we're doing 13 times 4. That means we've got 52.
did you just quick max that?
Just quick max it. Then I'm also going to do the back of the bottom because I know it's the exact same. Right? If I picture this back bottom part, it would be the exact same shape as the front. And you guys are getting really good at being able to identify that stuff.
Thanks, bro.
I got you. Then we're going to do the side of the bottom. Right there.
7 times 4.
Just giving us the whole package.
7 times 4, 28. And if we do the left side of the bottom, it's going to be the same. Right, so I got my right side of the bottom, 28. My left side of the bottom over there, also 28.
And
Then we do the-
do it 2 more times. 28, 2 more times.
Nope, not quite.
For the top
Where
of the bottom rectangle.
You're talking about this right here?
Yeah.
We're going to talk about that in a second because I got a good trick to tackle that. So I'm going to talk about the bottom of the bottom, like on the ground there.
13 times 7.
Yeah, you can't see it, but you know that it's a rectangle. It's length 13 times 7, which is the width. Which I'm not going to trust my little quick facts there, so I'm going to put that in. 91.
No, you don't do 91.
Okay. My trick. Because the top of the bottom shape is kind of weird. Again, I'm going to try to use an example. Maybe my phone will be better. I need some. Anybody have a good like rectangle right now, Tommy? A little thicker. You're kind of in the same boat as me.
Pretty thick.
Buck. Okay, so
Yeah, you know.
if we picture this is kind of our shape, right? We got our bottom of the bottom there, and then we got our nice fancy Kleenex box on the top. When I go to calculate the top of the bottom shape, you don't need to break it into all the sections. The reason being is if you think about painting this, when you painted the bottom, which was that, it's the exact same as the top if you look at it from that direction, right? It's still the same size as the book. If you did this, plus this, it would be the exact same as the bottom. So you can double the bottom and then not have to worry about any of the tops. Yeah.
What?
So the bottom and the top are the same?
Yeah, but the top is this top right here, green, plus this top right here in green, plus this top on the side in green. If you added all 3 of those sections, it's the exact same thing as that bottom side.
I don't understand. How would that work if that one's 5 and the other 2 looks
The
like
bottom on the box is the same width as the top.
Yeah, so if you think about it, this is 5, and then this is probably like 4 to get you to 9, and this is 4 to get you to 13. So it's the same, it's just broken up.
The same length. The box is the same length as the bottom here, so all you have to do is go.
So does that make sense? We can just double that bottom? So the tops would also be 91. And we're going to try to utilize that trick as often as we can. Where one, see how it's,
So
see
if
now?
you sink that rectangle into the other rectangle,
It's the same. That's,
You're a sneaky guy.
isn't that handy?
What if you just stick one shape and then added the 2 shapes together?
The problem with that is, like, you could do it that way, as long as you understand that you don't want to count the bottom of this shape
Yeah.
because it's overlapped. Yeah, that's fine. That's
Take that all the way out.
Yep.
And then you can only do like 2 halves.
Yeah, if you want to do it that way, that works. If we're looking at our top shape now, we still have some sides that we haven't covered. So I got the front of the top. Thank you. Which would be 25. That means the back of the top would be the same.
Yeah.
And then we have the right side.
Which would be
5 times 7.
Yep. So the right side of the top would be right over here, which is 7 long, and then 5 up. So 7 times 5, which is 35. Awesome. And then the left side.
Add them all
You
together.
gotta add all that together.
I'm gonna let you do that because I really don't.
That's fair.
That's a lot of numbers to add.
And that's what you're gonna find with these composite shapes is it's so many. So try your absolute best to keep it organized. You'll notice that my strategy is to try to do it all in like a nice long line, and then I total up across the bottom. But it's hard. These composite shapes have a lot of sides. So if you lose track, you lose track.
Yeah, if you miss a number, you're out.
Total equals 52 plus 52 plus 28 plus 28.
You think you can quick math this?
Want to see?
Let's see.
I don't know. These are hard.
That's a challenge.
Okay, let me try. 35. Okay.
450.
So if I can do this, I can go 60, 80, that's 160. That's another 180, that's 260, that's 342, that's 352. No, 342, 392 plus 70 is 362.
I got 462.
Oh, 100 off? Actually, I think you're right. No, I think you're right.
Come on, Kennedy.
I know.
Professional.
Like, where'd I get my degree from? 462. I didn't add I missed a 1.
Wow, I bet you genius.
Yeah. My phone's smarter than you.
All right. So 462 feet squared would be the surface area of that composite shape. It's hard.
And then there's none.
All right, let's try another one. This one's harder.
But like, you don't do the interface of the circle.
Right. So if you're thinking about this,
Wait. Question.
yes.
Can you just do a sphere formula and just divide the answer into?
Yeah.
Oh, well, that's easy.
So there's 2 sections of this that you're going to have to cover. The first section, if you're looking at it, is going to be this part of the sphere.
You're going to do a circle then divide by 2.
Yeah,
Sphere
but
formula and divide by 2.
Yeah, so you go side.
gentlemen,
Half the volume.
remember that a sphere is a ball. It's not a circle. So when you're looking at your formula sheet, you're looking for like the globe, like the ball formula. And when you do that, it's only half of the ball. So really, you're looking for half the ball. Our formula for a ball,
Is that 5 times r squared?
I don't think so. Maybe.
Alright, what is it?
It's 4 pi r squared.
4 of that.
So if you look on your formula sheet, there's your sphere, right? The ball. The formula is surface area 4 pi r squared.
Mhm.
And then we're going to have to cut that in half to make it half of the ball. If you calculate that, we have 4 times pi times 4 squared. That would be 4 times pi times 4 squared, 201.061 dot dot dot. And then you want half of that.
Is it
So divide that by 2, and you end up getting that the ball part is 100.5309 dot dot dot. That's just the sphere part, the ball on the bottom.
But do you do the other? Do you do the top shape of the sphere, or can you skip the second step of that?
Now, if you think about that, if you think about just what you're like painting, you're just painting the cone part. You don't have to do the circle on the inside because it's covered up.
Step 2 of the
Exactly. That's why when we did our cone formula, I like to break it into 2 sections. There's the circle section and there's the cone section. We don't need the circle because you can't see the circle. So when I go to do that cone part or the incline, we know that it's It was pi rs, right?
What's the incline?
That's the cone section.
Yeah, but it doesn't say the.
We called it. That's just what we named
But
it.
it just says the height of it. Is the
Yeah.
height is-
Oh, what's the slant height of it?
Yeah.
Yeah, so we don't have to slant it.
Yeah. To find that slant height, you could do Pythagorean theorem, which is 10 squared plus 4 squared, which is 116, and then square root that. So I'll just give it to you.
Yeah, 'cause I was thinking that too.
Did you get the 5.5 cent?
Nope.
Thanks, Morgan.
You know where it says 201?
It's 10.8.
I appreciate your support.
It'll always be given to you.
You know where it says 201 decimal 0.61?
Yeah.
Repeats it, and it says half. Is that, are we halving it, and then is that the product below it?
Yes. Yeah, you want half the ball, so that's why we cut it.
Okay, so we found the full.
Yes. Yeah. So if we throw that in there, we got pi times 4 times 10.8.
I got 236.24.
Is that the final answer? Or is that the pi times 4 times 10.8? Oh, shoot. So we got pi times 4 times 10.8. You get 135.717. Yeah, that was too big, hey? Hey, not to worry about, Jaden. You then have your total, which would be those two things added together. The reason why we were doing surface area the way we were doing it before was so that we could tackle these composite problems with the exact same strategy. Try to see every single side that you can cover up and then add it all up to total it. When you do that, you should get a final answer of, Jaden, what'd you get? 230.
236.24.
Perfect. So 236.2, and that's centimeters squared. These composite shapes are challenging. Try to break it down by side. You can try the next one on your own. I'll give you, remember a triangle? Is base times height divided by 2. Okay, give it a shot. Oh, you're going to need 4.9 is this. 4.9 is this distance right here. So many shapes to it, right? Again, I'm going to try to just start from the bottom and work my way up. I also like to start at the bottom because it's easier. Like looking at this, I like to start with what I know. I can look at this front and be like, that right there is a rectangle. I know how to do a rectangle. And so if you start with what you know, it builds up confidence a little bit. And on tests, and that goes for any subject. If you're in a test, try to go find the questions you know. Do those ones first. It builds confidence. It also reminds you of what you do know, and then maybe you can apply it to what you don't know. And then if you ever get a test, I had a test once where I tried to do that, and I flipped the whole test, didn't find a single question I knew. Yeah, then you're screwed. But try to find something that's easy to start. If you can't, then you can cry after. Okay, this front side, if I'm looking at it, the front of the bottom would be equal to 8 times 14, which would be equal to something that my calculator will do for me, 112. I also know that the back of that bottom shape will be the same. Looking at your papers, you guys are doing a good job of being like, that's the same, saving yourself that calculation. Yes, sir.
Tomorrow, I want you to do all the math in your head.
I can only do so much of it. I can do,
Unacceptable.
yeah, I know. The decimals get hard, man. So if I look at the right side of the bottom, that would be 9 times a height of 8, which would be 72. So left side would be the exact same.
Pixelated.
The internet, it's happened now. It's happened 3 classes in a row that at this time the internet like just takes a hit.
Yeah, like this time.
It breaks.
Actually, it was earlier.
Yeah. All right. Our next one would be the bottom of the bottom. The bottom of the bottom, like underneath here. In this case, it would be 14 times 9, which would be 126. We can't use our trick to do the bottom must be the same as the top. The reason we can't do that trick is because those 2 top rectangles are on an angle. And I think it was Jaden who asked, if I put it down, would it cover the top? It wouldn't. It would be too big. So that trick doesn't work. So instead, you're going to have to calculate the top as its own pieces. We'll start off with over here, this rectangle. You good?
Yep.
Okay. So the right side top would be a rectangle. It'd be 4.9 times 9. If you throw that in your calculator, that's 44.1. That's also going to be the same as the left side top. Okay, so looking at my sheet, I've done my rectangles on the bottom, I've done underneath, I've done my rectangle on the top. What I haven't done is that front triangle piece, right? Sorry. I try my best to stay out of your way. This side of the class, I cut you off all the time when I'm walking around. That triangle at the front is going to be the same as the triangle in the back. To calculate the area of a triangle, is base times height divided by 2. The base of this triangle is this long side, which is going to be 14.
Remember the old days when you used smartboard?
I miss my smartboard.
And then you had to like sync it.
I liked my smartboard, man. I missed it.
I mean, why does Highlander still have various?
Certain classes were allowed to keep them because they have technology that like has to use
I
them.
mean, apparently she pays for it around now.
Yeah, she press pay for her own software and stuff. So this is 14. The height is not 4.9. The height is 5. Right? So make sure that when you're doing these triangles, you're getting the proper height. That's why they put that number on the outside for you. If you do that, you should get, then you want to divide by 2. If you do that, you should get 35.
When I did this, I got the answer 35.
Yep.
And then I started seeing you do like the front bottom, the back bottom, and it was like 112. And I thought I was wrong, so I erased all my work. And I followed like 2 steps, and I got 35.
But you got it?
Yeah.
You gotta just trust your gut.
No, it makes.
Because you're doing it right.
Okay.
Like if you
Is this necessary? Because like I'm not like undermining it. Because I know it's very helpful to see all the steps.
Yep.
But is it necessary?
well, what's another strategy you would take?
Well, I just did the finding. I just found the area of the.
Gentlemen, just wait. Someone's asking a question. David, hey, I can't hear.
I just found the area of the first was like just found the area of the triangle.
Yeah, man, if you can do that, then go for it. Yeah, that's fine. Yeah. That back triangle is also going to be 35, right? There is a triangle on the back here. Your final job is to total it all up.
Is it 536?
I'll tell you in a second. 652.2
I got that wrong.
inches squared.
That's off by like 3.
You're tight though. That's close.